Hello, this is your video lessons for section 3.2, which is going to be Introduction to Complex Numbers. This should be an exciting section for you because basically we are going to double your knowledge on numbers today. So it should be a pretty productive lesson as you get to learn a whole new set of numbers. Okay, so this is old stuff here. We're just going to try to remember how to classify some numbers. And what kind of number is 5/9? All right, well, is it a natural number? And it's not a natural number. Natural numbers are those numbers that come up easily when you're counting in nature, starting with number 1 and you're counting numbers. Is it a whole number? No. The only additional whole number to the natural numbers is the number 0, the number with a hole in it. So it's also not a whole number. It's not an integer because integers are your negative and positive counting numbers, and it is not one of those. Is it rational? Can it be written as a fraction? It sure can. It is a fraction. In fact, it is rational, which means it can't be irrational. Those would be your square roots of 2's and your pi's and stuff like that. And it's definitely real because we can put it on a number line. How about -17? Where would -17 fit in here? -17 is not natural or a whole number, but it is an integer. It is rational because it can be written as a fraction if I put it over 1, and that is also real because we can graph it on the number line. All right, so this is what we know so far about numbers, and we talked about this in chapter 1. So you have all these real numbers which we can graph on a number line. And then all of these are rational numbers. Rational numbers are anything that can be written as a fraction. On all of these guys can be written as a fraction. And then you have these weirdos, square roots of 2's and square roots of 2's and pi's, all these things irrational over here. I don't really like the way this looks because it indicates that there's some numbers that aren't in these. I think it would have been better off if half of this was irrational numbers and half of it was rational numbers, but this is what it looks like that they gave you, which is, I guess it's fine. I just don't love it. And we're going to talk about today these new ideas called complex numbers and this idea of an imaginary number. And then we're going to talk about the absolute values of such numbers. Okay, so the square root of -1. Oh, yawn. I'm sorry. That is so bad. I'm sorry that happened. The square root of -1. If I used to say to you, by used to, I mean like yesterday or a minute ago, the x squared is -1, you guys would be like, no, fake news. That's not true. There's no number in the world that you can square and get -1. But that was before today, because now we're going to talk about this idea called an imaginary number. An imaginary number is a number of the form bi, and b is a real number, and I is a square root of -1. So these are the two facts that I want you to know. And I do write it with a little tail so that it doesn't turn into a 1. I is the square root of -1. So while we used to not be able to do something like that, we all of a sudden are going to say, okay, it's all right now. We're going to say that I is the square root of -1. And the reason we're going to do that is because when you deal with parabolas and we do the quadratic formula, we talked about last week how these x-intercepts are zeros or roots, and you can do the quadratic formula to find these zeros or roots. Well, sometimes when we do the quadratic formula, you get a negative number underneath the square root sign. And how can that be? Well, it happens because do you see any x-intercepts here? No. So what's actually happening when I use the quadratic formula is I'm still finding roots. They just happen to be what we call imaginary because you can't see them. So we're going to define this value of I as a square root of -1, and that's going to say, hey, we're going to use this quadratic formula, but we're not really going to be able to see the results. And this means that I squared would be the square root of -1 squared, which would cancel the square root, and I squared is -1. These facts you must know. They're really the only thing to really know when you're talking about imaginary numbers. I think it's so important that it's probably on the next slide. There it is. The only facts you need to know. Only facts you need to know. If I is the square root of -1, then I squared is -1. All right, so let's practice a little bit with these imaginary numbers. So what happens if I had the square root of -36? Well, if I had the square root of -36, most kids are like, hold on, you can't have a negative there. Well, we're just going to change it. We're going to change it to -1 times 36. The square root of -1 times the square root of 36 is the same thing as that. And the square root of negative 1 we just defined as I, and the square root of 36 is 6. We're going to write it like this. We're going to write 6I because the directions said that they want the complex numbers, the imaginary numbers, to be in the form bi, where b is a real number. So we having this b is going to be 6 here, and then the I is afterwards. Now, most kids don't write it all out like this, and you're welcome to do it, but most kids see the negative underneath there, and immediately they're like, oh, can't have that. This is going to be imaginary. Correct. What is the square root of 81? 9. So you get 9I. So if there's a negative underneath, that indicates the I. Square root of 81 is 9. If you wanted to be fancy and write out all the steps, it would be negative 1 times 81. That's the square root of negative 1 times the square root of 81. Square root of negative 1 is I. Square root of 81 is 9. So what happens if it doesn't simplify all the way? It's not a big deal. We're just going to break it down to one of these guys to simplify it. So a perfect square would be negative 25 times 2. Those are the same thing. The square root of negative 25 times the square root of 2. Square root of negative 25, we just talked about that. That's like 5I times the square root of 2 cannot be simplified. There's nothing really wrong with this. In fact, I've taken classes where we just write the answer like that, but this particular text does want you to put the whole number part in front. So 5 square root of 2 and then the I afterwards. Just make sure that the I doesn't fall underneath your square root. So just a little bit of practice with simplifying square roots. And now we're going to talk about something cool about what happens whenever you simplify powers of I. So we know that I is just I, or the square root of negative 1. But what happens when you have I squared? All of a sudden you get something real. And because you get something real when you have I squared, we're going to spend a lot of time changing things to I squareds because it might make our life easier. What about I to the third? Well, what would that give me? Well, I know that I to the third is the same thing as I squared times I, and I squared is negative 1, so it's negative 1 times I, so I to the third is negative I. So I have an I here, I have a negative 1, and now I have a negative I. What happens with I to the fourth? Well, I to the fourth is super special because I'm going to take I squared times I squared, and that gives me negative 1 times negative 1, which gives me positive 1. That's great. So now I get 1. So what do you think is going to happen when you take I to the fifth? Well, 1 times anything is just itself. So if I change this to I to the fourth times I, that'll just be 1 times I, which gets us back to I. You also could have taken it and said that's I squared times I squared times I. Some people like to just deal with the I squared. That's negative 1 times negative 1 times I, which is still positive I. I to the sixth, well, that's just I squared times I squared times I squared, or negative 1 to the third power, which is going to give me negative 1 again. So it looks like I have I and the negative 1. I wonder if I'm going to get negative I again. And the answer is yes, I will. I to the seventh could be I squared, I squared, I squared times I. We already said that this is negative 1. Negative 1 times I is negative I. And I to the eighth gets us back to 1. So we call this a cyclic function. It's just kind of fun to say. And any I to any power will give you one of 4 answers. I, negative I, 1, or negative 1. All of the odd guys are going to give me an I or a negative I. And all the even guys will give me a 1 or negative 1. So when we simplify these, the first thing you should do is make it even. Because if you can make this I to the 23rd even, we know there's going to be an I because it's odd. But if I make it even, I can figure out if it's going to be negative or positive. Well, how can I figure out if it's negative or positive from this even number? Well, all I need to do is figure out how many I squareds, oops, that's not an I, it's a U, are hiding. So it would be I squared to what power? Well, if you divide it by 2, it'd be I squared to the 11th, because that's the same thing as I the 22nd. Well, I squared we know is negative 1. So it's negative 1 to the 11th power. If you have an odd number of negative ones, that's going to be -1, and you will get -I. How about I to the 37th? Same thing. It's going to have an I in it, but we need to know if it's going to be negative or positive. So change up to I times I to the 36. We still have the I, yes, but let's see how many I squareds are hiding in 36. I keep writing U. That's weird. So I squared to the 18, that's -1 to the 18. If you have an even number of negative ones, that's positive, you just get I. Even ones are easy already. You don't have to change it. You're just going to figure out how many I squareds are there. So that'll be I squared to the 41st, which will be -1 to the 41st, which is an odd number of negative ones, and you get -1. So simplifying powers of I, you're going to change it to an even and figure out how many I squareds are hiding. So what is a complex number then? Well, a complex number has a double bar C. And basically, every number you know is complex. All numbers are complex. So from the complex numbers, you have these real numbers, and then you have these imaginary numbers. So how are these real numbers complex? Because what you have is this idea of complex numbers being anything you can write like this, A plus BI. So maybe it's like a 2 plus a 3I, or a -4 minus a 5I. These are all complex numbers. Well, real numbers can be written that way. Real numbers can be written that way because you can write 4 plus 0I. We just don't write the 0I. We would just call that 4. The same thing with the square root of 2. You could write the square root of 2 plus 0I, but we just write a square root of 2. They're still real numbers. A and B are real numbers, but for real numbers, what we call the imaginary part is 0. So when you have A plus BI, A is what we call the real part. And in real numbers, that's the only part really that matters, because B, which we call the imaginary part, is 0. These guys up here, -4 minus 5I, -4 is the real part and -5 is the imaginary part. You make sure you keep the sign. 2 is the real part, 3 is the imaginary part. It's kind of like slope. You know when you had 5x in the equation, 5x plus 4? You know the slope is just 5, but sometimes kids accidentally want to say 5x. Okay, it's just the number in front. Same thing with the real and imaginary parts. Make sure you're just telling me the part in front of the I, don't say the I. So imaginary numbers are just, or pure imaginary numbers, they would have a real part of 0. So 0 plus 4I, or we would just call it 4I, or 0 minus 3I, or we would just call it -3I. These are called pure imaginary numbers, which has 0 for a real part, and here is a -3 for the imaginary part. So complex numbers are all numbers, and they could have both a real and imaginary part. They could just have a real part, or they could just have imaginary part. And never forget that I is telling us that it's a square root of -1. So here's another diagram of how this could look. There's all the real numbers, and here are the imaginary numbers, and then complex numbers would have both real parts and imaginary parts. So let's talk about these parts. We have a number, 7 minus the square root of 3I. Is 7 the real part? Sure is. It's in that real part spot. Is the square root of 3 the imaginary part? And be really careful because people want to say yes. But the imaginary part includes the sign. So it's actually not it, because negative square root of 3 is the actual imaginary part. Do we call 7 minus root 3 the coefficient? No, it's not like a variable. We're not going to call it the coefficient. Coefficients usually just have variables that go with it. And is that number the sum of a real number and an imaginary number? Kind of. The kids this morning wanted to call it a difference instead. So if you get hung up on that word, that's fine. But sum and difference is used interchangeably a lot if you're just adding a negative. So we'll go ahead and call it a sum of a real number and an imaginary number. Okay, so now we're going to graph numbers. You already know how to graph real numbers. When we first started learning how to graph numbers, you draw your number line. Everybody draws their number line like this. You can put -1 on here. You could put 2 on here. You just put dots on the number line. Well, if we're going to graph imaginary numbers, we're going to go up and down instead of left and right. You're still going to just count how many imaginary spots away you are from 0. So -2i would be down here, and 3i would be up here. So if you're going to graph something that has a real part and an imaginary part, what you're going to do is basically you're going to, if it has an imaginary part at all, it's going to be off of the real number line here. You're going to put stuff either above or below. So if you have -1 minus 2i, you're going to graph the -1 in the real direction, and then you go 2i in the negative direction for the imaginary. So really, -1 minus 2i is very much related to the point -1 minus 2, because this will be the real part, and this will be the imaginary part. So you went -1 in the real direction and -2 in the imaginary direction. So where would 2 plus 3i be? It would be 2 in the real direction and then +3 in the imaginary direction, and it would be right there. So let's practice with identifying where these numbers are. So where are these points if this is what we call the complex plane? Well, if it's a complex plane, then A is going -2 in the real direction and +3 in the I direction. So it'll be -2 plus 3 in the imaginary direction, I. B is -1 in the real direction and -1 in the I direction. So -1 minus I, or -1i. C is 3 in the real direction and -4 in the imaginary direction. So that's 3 minus 4i. And D would be 4 in the real direction and 1 in the imaginary direction. So it's 4 plus I. Now we're going to talk about this idea called absolute value. Now, what is absolute value? Unfortunately, a lot of kids really have this kind of messed up. A lot of kids want to say absolute value just means make things positive. Okay, well, kind of be careful with that because it's not really true. And when you say things like make things positive, what happens is when you solve square root equations, which that's not today's lesson, but let's say it was, and I said absolute value of x minus 2 equals 4, some of you might say, oh, you can't have that negative in there. You got to make it positive. And that's not really true. So what is absolute value? Absolute value is the distance from 0. So how far away is something from 0? So what this statement is saying here is that there's some number whose distance from 0 is 4. Well, there's two things that could be in that symbol that would make that true. 4 is 4 away from 0, and -4 is 4 away from 0 on a number line. So that means that this x minus 2, it could equal 4, or the x minus 2 could equal -4. Well, if I solve this, one of the answers is x equals 6, and everyone feels really good about that. It's positive. 6 minus 2 is 4. The absolute value of 4 is 4. It's true. But kids get a little confused by this one. When I add 2, I get x equals -2. Well, I can't have -2. It has to be positive. No, it's not true. -2 minus 2 is -4. When I made it positive, that's where the 4 came from. So be careful when you think makes things positive, because I think it confuses kids. What we need to think of it is the distance from 0. So how far away is 2 from 0 on a number line? Well, it's 2. How far away is -3.5 from 0? Well, it's -3.5. Now, when you graph the imaginaries, 0 was right in the middle still. How far away was -1/2 I? Well, if this was -1, -1/2 I is here. How far is it from 0? Absolute value is always a positive because distance is positive, and that's why it is. So it's positive 1/2. But there's no I. It's not I away. It's just positive 1/2. It's positive and it's real. We're not going to use the imaginary. It's just 1/2 away. How far is 2i away? Well, it's just 2 spots away. It's just 2. What about these real strange looking guys that we just looked at on the last page? Let's see if I can go back here. What if I wanted to know how far A away is from 0? How far is A from 0? Well, you have to take a direct path. So you're looking for a diagonal length. So what we're going to do is you're going to do the distance formula. They're basically asking how far away is that, and you're going to use distance. Distance formula, a lot of kids have a hard time remembering. So it would be real easy though. Kids are really good at remembering this guy, the Pythagorean theorem. So basically, how far is this? Well, if this is 2, and this is 3, how far away is A? Well, you can do 2 squared plus 3 squared, and that's going to be that distance squared. So that's 4 plus 9 is the distance squared. Square root both sides, and that's the square root of 13. So how far apart is A, which we knew that A was at -2 plus 3i. How far away was it from 0? Well, the absolute value of -2 plus 3i is the square root of 13. So when you take the absolute value, you get something real and you get something positive. It doesn't have to be nice. It doesn't have to look a lot like what we started with. But you're going to take that point on the complex plane and you're going to do the distance formula. Now, because you're always using 0 as one of your points, there is a shortcut if you want it. The shortcut is the square root of a squared plus b squared, because this is the distance formula. And if you're plugging in 0 for one of your points, then you're just going to get a squared plus b squared. Okay, this is the Pythagorean theorem. You don't have to graph to do the Pythagorean theorem. You can just say, how far away is A? Well, A is 4. It's up 3 if it was 4, 3. You can kind of use your brain to picture where the point is, but you could also just use the formula if you want. So let's look at this guy. Which of these can be used to find the absolute value of 4 minus 7i? Well, think about it on the graph. It would be at 4 in the real part and -7 down here. So it'd be like at 4, -7. Well, if I'm going to do the Pythagorean theorem, this is 4 and this is 7. So what is this length? Well, it's 4 squared plus 7 squared equals the distance squared. So that's the square root of 16 plus 49. And when you're looking at the choices, I got this one. But if you use the square root of a squared plus b squared, you might get this one. That's okay, because the -7, when you square it, becomes positive anyway. So both of these would actually work. Now, when you do 4 plus 7i, that's a little different. When you're at 4 plus 7i, you're 4 in the real part, 7 in the imaginary part. So that's like right here. Pythagorean theorem, this is 4. This is definitely 7 this time. No way it could be -7 at all. So this one, you would be looking at the square root of 4 squared plus 7 squared. If on your homework they ask you to do something like this or your quiz, I would probably go with the sign that shows up. But if it said you missed something because you were always making it positive because you were doing Pythagorean theorem, just talk to me about it. Okay, I think that's it. So you should be able to practice it. Hopefully you understand complex numbers a little bit better, and we'll look at it more on the next lesson.